All right, so here is a stoichiometry problem. Okay, 3 grams of silver chlorate are dissolved in water. 4 grams of aluminum sulfate is dissolved. Should have put a D there. Is dissolved in water in a separate beaker. And if the 2 beakers of solution are mixed together, what theoretical yield of solid will be produced? So the first thing we're going to have to do is to figure out, this is definitely stoichiometry. If you're doing stoichiometry, you have to balance the equation. So the first thing I want to do is to figure out the equation. We've got to figure out the formulas first. The 2 formulas for the reactants, you have to figure out from the name. The 2 formulas in the products, you have to figure out from the classification of the chemical reaction. Okay? So let's start with silver chlorate then. Silver is Ag, and it has a 1+ charge. Chlorate is ClO3, and it has a 1- charge. And that means that this, put with this, it has a 1-to-1 ratio. The 1+ cancels out the 1-. You also have to memorize your solubility rules. Chlorates are always soluble, so if this is dissolved in water, it's aqueous. Well, it pretty much tells you it's aqueous in the problem. Okay? Then we're going to put that with the aluminum sulfate. Okay, aluminum is this, and sulfate is this. Now what I'm writing here is the charge. Aluminum has a 3+ charge. Sulfate has a 2- charge. Now there are some monoatomic and polyatomic ions you're supposed to memorize. Okay, so if you don't have those committed to memory, I highly suggest you go back to that list and memorize. Would you put your name on this and put it in your phone? All right. So look, huh? There's just one reaction here. So yes, we're putting them together. The 2 beakers of solution are mixed together. Okay. What did we remember the lab we did when we were the precipitate, and we filtered it out? Well, you should try to remember it. So then if aluminum has a 3+ charge and sulfate has a 2- charge, the only way to get this charge balanced, to have a neutral charge overall, is if I have 2 of these and 3 of these. So I'll put a suffix 2 here, a subscript 2 here, and a subscript 3 here, and that'll balance it out. And it is aqueous. It says so, but you need to know that most sulfates are always aqueous. This is memorizing the solubility rules. Most sulfates are always aqueous. There are some exceptions, but aluminum is not one of the exceptions. All right, so those are our 2 reactants. We're going to put them together. We're going to mix these up in separate beakers. We're going to put the 2 beakers together. We're going to mix the solutions together, and it indicates to you you're going to get some kind of a solid. So we know that one of the 2 products on this side, at least one of the 2, has to be a solid. So we have an ionic compound here and an ionic compound here. We know they are ionic compounds because they both contain polyatomic ions. The chlorate and the sulfate are polyatomic ions. The 2 ways that I've given you or suggested that you identify an ionic compound is to look for polyatomic ions. That will tell you have an ionic compound. Or if you have a metal bonded with a nonmetal, that'll tell you have an ionic compound. Okay? So if we have 2 ionic compounds, then the most likely kind of reaction you're going to get is double replacement. Okay? So the front part of this then is going to go with the back part of this. So we're going to put the silver with the sulfate. Okay? And then the front part of this is going to go with the back part of that. So the silver has a 1+ charge. Sulfate has a 2- charge. So I need 2 silvers. Silver sulfate. Sulfate is one of those compounds that is mostly soluble, but it's not soluble when you put it with silver. So this is the solid. Then the front part of this goes with the back part of this. Aluminum has a 3+ charge, and chlorate has a 1- charge. So I need 3 of these chlorates. Okay? Chlorates are always soluble, so this is aqueous. So we have, in order to balance the equation, you had to predict the products. You have to predict the products from classifying the equation. Okay? So we're tying in a lot of things together that happened, you will learn about over different units. Okay? We're learning to write formulas from names. That's the nomenclature unit. We're learning to classify equations. We're learning to balance equations. Okay? We're learning to balance the whole equation when we're done. So now we're ready to balance the overall equation. Now remember, once you balance that should be a 3 here. 3. Okay? Once you balance the overall formulas, you don't change any of these subscript numbers we put in here to balance it. You have to use coefficients to balance the overall equation. Okay? So I'll let you guys work on balancing the equation now. So we're doing an atom inventory. We're counting up all the atoms we have on the left-hand side. So I've got 3 oxygens here. Over here, there's 4 oxygens in the sulfate times the 3. That's 12 oxygens, right? So 3 plus 12 is 15 oxygens. That's where I got that from. And then, of course, 2 aluminums and 3 times the 1 sulfurs there. Okay? On the other side, I get 2, 3, 13, 1 and 1. So the 13 oxygens, and don't try to save on pencil lead or pencil graphite. Use it to write this stuff out. It'll help you a lot. Okay. So the number of oxygens we have on this side is we've got 4 here, plus the 3 times the 3, that's 9, and 4 plus 9 is 13. Okay. So, do the math on paper so you don't miss anything. It's always a good idea to write it down, especially when there's a lot to keep up. And there is in this problem. I purposely gave you a problem that was complex so we could practice a lot of different skills at one time. Okay? Well, that's where you end up, with 30 oxygens, yes. Huh? Whichever produces, the way that you're calculating your stoichiometry, whichever produces the least amount of product that'll be your theoretical yield. Okay? All right, now let's go back. Let me go back for the rest of the class what we're doing here. So I'm looking and I see I have 2 silvers on the right and only 1 on the left. So I want to put a 2 in front of this silver chlorate. It's going to change the number of silvers and chlorines and oxygens. I now have 2 silvers, 2 chlorines, and I'm going to recount the oxygens. 2 times 3 is 6, plus 4 times 3 is 12. So at the moment, I've got 18 oxygens. Okay? All right. I'm looking over here on the left and the right here. I see the chlorine is mismatched. I've got 2 on the left but 3 on the right. So I need to multiply this side where the chlorine is by 3 and this side by 2 to get the same number. Does that make sense? Okay, so we can do that now. We can change this from a 2 to a 6 because that's what I get when I multiply it by 3. Okay, and the other side where the chlorine is, I need to multiply that by 2. All right, now that means we're going to change the number of silvers and chlorines and oxygens again. And over on this side, we're going to change the number of aluminums and chlorines and oxygens. So I've got to recount all that. So 6 times 1 silvers is 6. 6 times 1 chlorines is 6. And the oxygens, 3 chlorines times 6, 18. 4 times 3 oxygens here, 12. That's 30 oxygens. Okay? So 30 here. All right, over on this side, let's see, we're going to have 2 times 1 aluminum in the formula. That gives me 2 aluminums. Let's see, I've got 3 times the 1 chlorine, then times 2, that's 6 chlorines. And the oxygens, I've got 4 there. 3 times 3 is 9. Times 2 is 18. Is that right? 4 and 18? 22? Okay. All right. Now I can see that I've got things balanced, but except for, well, we don't have the oxygen balance. We want to save that for last. So we're going to go down here to the sulfur where I've got 3 and 1. I need to put a coefficient 3 in front of the species that contains the sulfur. And that changes the number of silvers, sulfurs, and oxygens. So I have 3 times 2 silvers, that's 6. 3 times 1 sulfur, that's 3. And the oxygens, 3 times 4 is 12. So 3 times 3 is 9, times 2 is 18, 30 oxygens. All right? And looks like everything's balanced now. Does that make sense? So you probably just stopped 1 step too early. Okay? All right, now in the problem then, We have 3 grams of one reactant, the silver chloride, that's 3 grams. I'm just going to pencil it up here just to help me keep up with what I'm doing. And 4 grams of the aluminum sulfate. All right. And it says we have 2 grams of solid. That'll be later on, but I'm going to go ahead and put the 2 grams above this just to kind of keep up with things. Okay? Now then, the way that I've taught you to figure out limiting reactants. So, Andrew, if you'll pay attention here because I'm going to show you the way I teach it to you. You did it a different way, which is fine, but I'm going to show you again the way that I've been teaching it, okay? So I'm going to start with this amount of this reactant species and calculate to this amount, or calculate to the other reactant species, and see how it matches up with the starting amount. The first thing I'm going to do is convert that into moles. And to convert grams into moles, I need to calculate molar mass. So I like to do it down at the bottom, not that it really matters that much. I've got silver and chlorine and oxygen. Okay. And I'll go to the periodic table and find the masses of these things. Silver is 196.97. I look at gold, sure did, didn't I? 107.87, thank you. 107.87. And I have only 1 in the formula, so times 1. Chlorine is 35.45. There's only 1 in the formula. And you need to be careful because this coefficient here, 6, has nothing to do with calculating molar mass. All you're going to look at are the number of atoms in the formula when figuring out the molar mass. Okay? So don't multiply silver and chlorine by 6. Okay, you multiply those by 1. Oxygen we multiply by 3 because there are 3 in the formula. So oxygen's atomic mass in this class is 16.0 times 3. 107.87. 35.45, and 16 times 3, 18, 48, okay, and you already added all these together. What'd you get? 191.32, okay. There's no empty slots over here. Remember when you're doing addition and subtraction, anytime you have empty slots to the right, you have to round off a digit in the bottom, but we don't have that here. So this is grams of silver chlorate, AgClO3. Okay, and that's equal to 1 mole of silver chlorate. All right. So then that's going to allow me to build the conversion unit I need up here. I'm going to put grams, this part of the equality statement here on the bottom, so I can cancel grams on the top. One mole goes in the top here. And if I cancel as I go, this is the dimensional analysis part of this, then I have moles. Once I have moles, I can use the coefficients in the balanced equation to write a molar ratio. It's a 6-to-1 ratio. So I've got 6 moles of silver chlorate and 1 mole of aluminum sulfate. And cancel as I go. And I am now at moles of the second species, the other reactant. I've got to convert that now to mass to compare it to the original amounts. So I need another molar mass calculation, this time for aluminum sulfate. In the formula, there are 2 aluminums, 3 sulfurs, 12 oxygens. Now your calculator won't show those two zeros right there. Okay? You need to be aware that there are two zeros here, and if we're adding that to itself 12 times, there are still going to be two zeros over here. So you need to know there are significant digits there. So we're going to add this up. Why do I have two of these open? No, it doesn't matter. All right, so this is grams of aluminum sulfate, and that's equal to 1 mole of aluminum sulfate. And I can build another molar mass conversion unit up here, only this time moles are going to go on the bottom so I can cancel those moles. Cancel moles and aluminum sulfate. We're ready to calculate an answer.
You took the 342 on top for a bottom.
342 goes on the top because moles have to go on the bottom. All right, so is that what you guys got for the second reactant? That's not what you got. Well, you didn't do it that way. Why do you even say anything? All right. Now this has to be rounded off to 3 digits. Leading zeros are not significant. 1, 2, 3. We're going to underline the 1, 5, 6 here. We're going to draw an arrow, which is our operator for showing a rounding off, and put 0.894 grams of Al2SO43. Now that's going to tell us what our limiting reactant is, and here's how we do it. This is the amount that's going to be used up in the reaction if I started with this amount of the silver chlorate. I've got way more than I need here. Okay, I've got 4 grams, and this is like less than 1 gram. So this is going to be in excess. It's going to be left over. That means that this species, silver chlorate, is the limiting reactant. All right, since that's the limiting reactant, that's the one we're going to use to find the theoretical yield. So we start another stoichiometry problem with that starting amount. Now, a lot of students will make the mistake if they get the limiting reactant down here, they'll take this amount and put over 1. Don't do that. You start with the given amount, okay, what is given in the problem. Okay, that's the amount you're going to start with. So the first couple steps are exactly the same. Yes? That's correct. If we start with this amount of the silver chlorate and we react it with that 4 grams of aluminum sulfate, only this amount will be used up. So there's more than 3 grams of this stuff still left over in the solution. Okay? There will be stoichiometry problems on the exam. It probably won't be quite as complex as this, but I'm giving you one that's complex now to go through all the stuff. We cover a lot of territory. Okay, so you can be prepared to do the more likely, slightly more simple problems. Okay, but you still have to do all the steps. All the steps have to be done. Huh? Well, you gotta plan your time. Okay, there's 75 questions on the test. You might have 6 questions on this one problem. That make sense? It's possible. Okay. So we need a molar ratio here to go from the reactant that we started with, the limited reactant, to the product we're seeking. So this molar ratio will be different. We're going to put this on the bottom because that's what I have on the top here. Let me cancel units and species here. And so we want 3 moles of this. And then we're going to have a molar ratio, a molar mass conversion unit here. Because we've got to get mass of this silver sulfate. Every time I start to say that, I start to say silver sulfur. Good movie. Okay. All right, so let's do the molar mass calculation for silver sulfate. Oh, oxygen. All right. So the silver is 107.87. The sulfur is 32.06. And oxygen is 16. And in the formula, I've got 2 silvers, 1 sulfur, and 4 oxygens. All right, so the molar mass is this, and this is grams then of silver sulfate, and that's equal to 1 mole of silver sulfate. Okay, so we're going to put that number, the grams, that number on the top. Cancel moles and silver chlorate and moles and silver sulfate, and do the math. This times that, then divide, hit enter or equals, then divide by this, then hit enter or equals and divide by this, and hit enter to get a final answer. All right. So we get this many grams of silver sulfate. All right. We need to round it off to 3 digits because I've got 3 digits here. Of the measured and calculated numbers, those are the only ones we use for figuring out the significant digits in a multiplication division problem. This 3-digit number has less digits than this 5-digit number or this 5-digit number. So we want 3 digits in our final answer. And we get 2.44 grams of silver sulfate. And that's the theoretical yield. Okay? That's the first part of the question. What's the theoretical yield of the solid? Now we want to know about the percent yield. The percent yield is a whole lot easier. Once we get this, it should be fairly easy. It says we're going to get 2 grams of solid. We're going to collect 2 grams of solid at the end. And this is our solid. It says so right here, solid. So 2 grams of silver sulfate. That's our actual yield over 2.44 grams of silver sulfate. That's our theoretical yield. So actual yield over theoretical yield, then times 100 to get a percent yield. Anytime you're calculating percentages, if you're doing it right, you should cancel units. This is a unit-less answer. Okay, now, I've said this before, but occasionally in the food industry, for example, they'll do a percentage with has grams or milliliters, which doesn't make any sense at all. But that's what they do. In a chemistry setting, you'll always cancel out units. In fact, I think in a physics setting, you'll do the same thing. Anyway, in this case, we also happen to cancel out the species, but that doesn't always happen. All right, so we're going to do this math then. And I get 81.9672. Percent. And we need to round that off to 3 digits. So 1, 2, 3, round off those digits. Draw an arrow to show that I'm rounding off. That's the only operator that's allowed to show rounding off. This 6 makes the 9 round up to a 10, which makes this a 2. So it's 82.0% yield in silver sulfate. All right.